Hi all, welcome to Onion GCP Data Engineering. So in this video we'll talk about BigQuery table partitioning. Okay, so as you most of you already know, a partition table is divided into segments. Okay, we call them as a partitions. Okay, so basically that makes it easier to manage and query your data, right? So there are two major end goals to partition the table, right? So one is to improve the query performance and one is to save your query cost. Okay, so you already know, right? So how this BigQuery cost will be calculated, right? Based on some parameters, right? So one important thing is anyway, storage for storing the data. Okay, and this is very important actually. Bytes read by query. Whenever you try to execute query, right? So the amount of data it's going to process through that query, based on that, the BigQuery cost will be calculated, right? And there is another parameter for streaming also there is a cost, but here that is out of context. So this is very important, right? And next, in order to apply partition on any table, you need to have a column, suitable column for that, right? Okay, to partition a BigQuery table. Okay, and so once you partition the table based on some column, okay, so you have to apply filter based on that column. Then only BigQuery will just scan the table based on those partitions. It will just ignore the other partitions. This particular concept is called partition pruning. This is very important concept. So you have to design and write your query such a way that it should use that partition column, so that it will only scan portion of the table based on the partitions. Okay, that filter, that's where it will save the query cost, right? Since it is just scanning only limited partitions, obviously the amount of data it's going to process to that query will be reduced. Okay, so this is how it will save the cost, and also it will save the performance also. Obviously you have less number of partition to be scanned, so you are going to have a better performance, right? So when to use partitions? There are some, what are the different scenarios when you consider partitioning a table, right? If you have to improve the query performance by scanning portion of the table, as we already discussed, in that scenario you are going to partition table. And there are cases where sometimes there is a complex query when you try to execute it, so you will encounter an error called quota exceeds. In that case also, to limit the table operation, right, to specific portion of the column values, definitely you are going to partition the table so that it will scan very limited partitions based on that filter condition, right? In that case also you would be using partition. Okay, so I hope you are clear. Then now we will see the types of table partition BigQuery supports. Okay, the first one is integer int partition. So in this case you need to have a integer data type column inside your table. You are going to apply partition on top of that table. This is a simple example. For example, you have integer range from 1 to 100. If you have to divide that table into 10 equal partitions, so this is a criteria. Okay, so 1 to 100 interval value, 100 by 10, you are going to have 10 equal partitions. Okay, the next thing is time unit column. So if your table is having date or date time, timestamp, data type columns, you can apply partitioning on any of this column. So BigQuery supports daily, hourly, monthly and yearly partitions. So hourly is the lowest granular partition supported by BigQuery. These are the few examples. Okay, the next one is ingestion time partitions. Okay, but here, so this column does not exist in the table. So based on the data coming into the table, based on the time or timestamp or date time, we are going to apply partitioning on top of that table. This is also providing pseudo column, right, for that partitioning column. For example, let's say if you are going to apply partitioning on top of timestamp, this is a pseudo column which we are going to use for applying filters on partitioning column. Partition time is equal to timestamp, partition date is equal to date. Okay, and here also you can have daily, hourly, monthly and yearly partition. Okay, So along with this, there are special partitions supported by BigQuery. For example, let's say there are null values. To store those null values, BigQuery will use this null partitioning. And for example, there are some values not falling under any of this partition range. To store those values, BigQuery will use this unpartitioned partition actually. So I hope you are clear. So we do have some limitation with respect to the partitions, so we can discuss that. The first thing is we cannot use legacy SQL for querying partition table, okay, and it does not support partition on multiple columns. That means you have to define partition on more than one column, so it does not support. Clear? And also BigQuery does not support partitioning on repeated, that is array data type column, and also if you have a struct data type or record data type or nested data type column, and inside that nested column you are going to have a leaf nodes, that means child columns. So BigQuery does not support partitioning on those leaf nodes, okay. So I hope you are clear. So next, move on to the demo slide. In the demo we will try to see example for each of these partition type: integer int, time unit, and also ingestion time unit, okay. And yeah, so the main purpose of partitioning is able to save cost and also improve query performance, okay. So now let's quickly move to the demo. So for this demo, I have already have these SQL queries to explain all this partition with example step by step, okay. So let us go to those example. So what I'll do, I will try to make use of public dataset table to explain all these examples, okay. So what we will do now, we'll try to examine this table. Just try to examine this table, click on details. Now you can see the table size is 193.58 megabytes, okay, and we have these many rows, okay. Now what we will do, we'll try to analyze the data. For example, let's say if you have to partition this table once it reaches to few terabytes of data, right? Now you have to select the appropriate column for partitioning, okay. Now so we'll try to examine this table. Do we have any date column available as part of this table? Now you can see there is a date column, this is a timestamp, okay, that is start time, okay. Go to the schema. So this is a timestamp column. Definitely we can define a partition using this column, okay. So for that, now you know on which column you can define the partition. Now you have to know what level of granularity you have to define your partition, whether it is a yearly partition, whether it is a monthly partition, or whether it is a daily or hourly partition, okay. For that you have to analyze the data by querying the table, okay. For that I have few queries. So let me run this. Okay, now you can see this is the minimum timestamp we have, this is the maximum timestamp we have. That means from 2013 to 2023. That means data is basically spread across, that means distributed across multiple years, right. And now we know we can consider yearly partition. I would like to further analyze this table by using some more queries, okay. I'll use this query. So what I'm doing, so for each month how this data is distributed, okay. So run this query. Monthly also okay, and we are going to have 109 partitions, okay, with this existing data, okay. And always remember, BigQuery right now it is supporting maximum 4000 partition per table, okay. So you have to define your partition criteria by keeping few points in mind. One is BigQuery supports only 4000 partitions, and how the data is distributed across different date, time or timestamp granularities, okay. So yearly, monthly and date and also hourly, okay. So it look like monthly also okay rather than year. In year you are going to have lesser partition, but monthly still it will improve the performance, okay. So now we will also try to see how the data is distributed across day. So you are going to have 3294 partitions, okay, already. So you can see there are very less number of partition value for each of this partition, date partition. So I don't think so date is appropriate granular level. So in order to partition this table for the future data, you have to expire few of the old partition, and then only it will allow you to further partition this table. Okay. So I hope you are clear. So here also we can see this query. Okay. So yearly we are going to have 11 partitions, and see, you can see the data is almost distributed across different years, but I would rather prefer monthly partition. Okay. So let's see, it's up to you. Based on your requirement, you have to select appropriate granularity of the partition. Okay. So now we are going to partition this table based on the month, right? So this is a syntax. You have to use timestamp, truncate, and then month. That means this value will be truncated to the month value. Timestamp, it will look like this. Okay, now you can see everything is truncated. You are going to have, so the date timestamp value will be truncated to 000, date value will be truncated to the first day of the month, and this is our monthly. So right, I hope you are clear. Now let's create this table. This is going to create partition table based on the monthly value. Now the table has been created. Now what we will do, we will try to insert the data into partition table, but before going to the next step, so BigQuery also supports partitioning table based on some SQL query result. For example, if you observe this particular DDL statement, so I am trying to partition this table based on the start time of this table, that too truncating that timestamp value to the day or date. Okay, so that means it's going to partition this table based on the day or date. Okay, just I'll try to execute this subquery. The results would look like this. Now these are the different partitions it's going to create. Okay, so I hope you are clear. So I am not creating this table, just to explain you, have these details over here to explain you this concept. Okay, so I hope you are clear. Now what we will do, we'll try to insert data into this partition table that we have created in our earlier step. Okay, so what I'm trying to do, using this DML statement, I'll try to insert the data. Again, this is a unpartitioned table, this is a partition table. Now run. Okay, now it has inserted these many rows. Over here you can see same number of rows. Okay, so now we'll try to query both of these table. One is partition table, one is unpartitioned table. Okay, so for that what I'll do, so this is a unpartitioned table. What I'm trying to do, I'm trying to apply some filter based on this timestamp column. So this is an unpartitioned table. Now we'll see how much amount of data it's going to process. Okay, so for that it's going to process 193.58 megabyte. Okay, so run this. Yeah, this is the, so it took 2 seconds. Okay, since it is very less data, so you won't see that difference, right? If you have a huge data, then you will see the difference in performance, but the amount of data it's going to process, you can see the drastic difference. So in unpartitioned table case, it was taking 195, it was processing 195 megabytes data. Now we'll try to query the partition table. Now we'll see the difference. Now you can see it almost reduced to the half, right? Earlier it was 195, almost not even half, 1/3 actually. It's now going to process 58.48 megabytes. Now you see the difference. Now you can imagine how much cost you are going to save with the partition table if you have the appropriate filter applied based on that partition column, right? Just run this. Right, so since it is a very less data, you won't see the difference, but if you have a huge data, you can see the difference in the performance also. Okay, I hope it is clear. Now what we will do, we'll try to see how we can partition table based on the integer n. Okay, so for that what I'll do, I have this query from the public data set. I'll try to examine this data. Just run this. Okay, now you can see the data. So now you can see there is an integer data type column, that is ID. right? Basically it is in an order also. Now we can apply partition on top of this integer data type column. Okay, so just to show demo, though we have the timestamp column, I would like to use this integer data type column to partition table based on that integer array partitioning. Okay, so for that, okay, what you can do, so this is the maximum value which is available in that table for that integer data type. What I'll do, so integer start range is 0, this is the end, and I'm going to partition the table based on this interval value, that is 1 lakh. Okay, so now let me partition this table. Let's run this. That means we are going to create partition table now with the integer in partition. Okay, now this table has been created. What we'll do, we'll try to insert some data into partition table using unpartitioned table data, right? This is the DML statement I'm using. See, okay, it's going to insert 14.73 GB of data. Now it has inserted the data. Now what we will do, we'll try to query partition and unpartitioned table. So this is unpartitioned table. So I'm applying filter based on this ID. So I'm also using this between clause. Now let's try to see whether it is going to scan full table or not, right? See, it has inserted this much data and now it is going to process this much data. That means you are going to pay amount for this 14.73 GB data, right? So now we'll see, we'll try to query this table. Yeah, results are there. So it took lesser time only. Now you can see bytes build 14.73 GB, right? So now what we will do, we'll try to query partition table, same query, but we have partition on this ID column. Okay, so now we'll see how much amount of data it's going to process. Now you can see just processing 16.69 MB of data. In earlier case it was processing 14.73 GB. Now you can imagine how much data you are going to save with the partition table if you apply correct filter condition based on the partition column, right? So this is the greatest advantage to save the cost and also to save the performance also. Okay, yeah, now go to the job information. Now you can see bytes build 17 MB. Earlier it was 14.73 GB. Now you know the power of partitioning the table, right? So but you have to appropriately use the partitioning, right? You can't use it everywhere. Wherever it is really required, then only you will have to use partitioning the table. Okay, so I hope it is clear. So we'll try to basically create a partition table based on the ingestion time. Okay, so here what I will do, so I will try to create a partition table, okay, based on the ingestion time, that too hourly partitions. I'm using the granularity is in hour. Okay, and here just examine this DDL statement. Okay, you can see there is an options also. So one is partition expiry day, one is require partition filter. That means if you have to basically expire your table partition after certain amount of time or duration, you can use this option. All these are optional, it's up to you whether if you really wanted it, you can use this. And this is when you create the partition table, if you have to use your partition column in your filter condition as a mandatory, then you have to go for this option. Otherwise, if you don't use that partition column in your filter, when you are querying the table, it will throw an error. Okay, so I hope you are clear. Now we are going to basically create this table. Run, it will create this table. Okay, so now what we will do, so I am not going to ingest any data, but I will try to show this how this partition or pseudo column can be used to query your partition table based on your ingestion time, right? So as I already told, this is also supporting all the granular level like hour, month, year, date, right? So now you can use this is okay. Now you can, that means you are going to query this table based on this criteria. Yeah, Now you can see this is going to query partition which are greater than this value, right, over here. That means we are going to scan only portion of the data based on your ingestion partition time, right. So I hope you are clear, and also you can use this between clause also if you have to query table based on some partition range, right, you can use that. Okay, so yeah, now you can query that. Since this table doesn't have any data, so you can see the no data, but this is a concept, right. So this is a pseudo column you can use to query your partition table. Okay, so now you can also alter your partition options. Okay, so using DDL statements, for example, let's say, so if I don't specify or define any options while creating the partition table like expiration date or required filter, so later point of time if you have to apply those configurations, definitely you can use this DDL statements. Okay, this option is available. So just by running this DDL statement, it will apply all these options on top of this partition table. Okay, right. So now it's clear, I hope. So this is how you can use the partitioning to save query cost and also to improve the performance of a query. Okay, so I hope it helps you. So that's it for this video. Thanks for watching. Thank you.